The University of Queensland has over 400 buildings spanning 40 sites. It is home for hundreds of institutes, schools and centres. UQ has made effective use of IT. It uses IT to attract, enrol, teach, assess and graduate students. It uses IT to create, store, protect, share and publish research material. In fact, UQ uses IT for over 130 different purposes and has over 600 core IT services. The organisation has become totally reliant on IT. An audit of IT services at UQ was performed to identify and understand the services being run at UQ, to assess the importance of each service, document who looks after them, and how they interconnect. Most importantly, to identify the risks. Risks are divided into three categories. Confidentiality, the risk of unauthorized access to data. Integrity, the risk of data being changed or incorrect. Availability, the risk of the service or data not being available when needed. This CIA classification is a common way of representing risks in security standards. The risk of confidentiality is gauged by the type of data stored in or captured by the service. For instance, course and subject information may be a 1, whereas student identity information might be a 7. The integrity requirements for the data depends on the system that is using it. Getting a student name wrong in the student portal may be embarrassing, but it is far more important that it is correct when printing their diploma. Availability or uptime will vary for each service. The e-learning system might need to be up 24/7, whilst the timesheeting system doesn't have to be as reliable. For each service, we want to set a target CIA and an actual CIA. Questions about a service can contribute towards setting a target CIA. For instance, the data the service uses, the impact of the service outage, data accuracy requirements, and availability requirements. Other questions can be asked which contribute towards setting an actual CIA. In other words, what controls are in place to protect the service in the three areas. For instance, is the service behind a firewall? The type of equipment being used? The location of the equipment. Is it in a secure data center? What backup and recovery strategy is in place? In all, 35 questions are asked for each service, resulting in over 20,000 pieces of information about our IT services we didn't previously know. All this data is captured using a web-based system, which allows staff to enter the details of the services they look after. The data is then processed centrally for reporting. Using ServiceView, we are able to delegate the task of adding a new service, setting service dependencies on other services, and setting data center dependencies. This is an example of using ServiceView to enter an IT service. In this example, we are entering Blackboard, the central e-learning system. The service name and description are first. Then the budget, business, and technical owners, the number of users of the service, the type of technology, i.e. commercial, open source or bespoke, the type of users, the license type, the impact to the business of an outage, and the uptime requirements. We then capture information about how well the service is being run. Do we keep logs? Is the service being monitored? Is it protected by firewalls? The type and location of the equipment this service uses. Do the engineers connect to the equipment securely? Is access restricted by IP address? More questions are asked about the service, including its life cycle, the release process, how incidents are logged, and what is the backup strategy. The service is then catalogued by its purpose. In this case, Blackboard is a learning environment. Next, questions are asked related to the data stored or used by this service, In this case, Blackboard stores identity details of admitted students, as well as other data relating to courses. Finally, the technology used by this service is entered, including operating systems, programming languages, databases, and web servers. Once this is saved, the service is added into ServiceView. Next, we need to specify what other IT services Blackboard needs to operate. In this instance, Blackboard requires LDAP, which is used for checking usernames, and the Exadata database servers. ServiceView catalogs service dependencies in 3 ways. The first way is that a service is required for service delivery. In this instance, Blackboard needs LDAP to operate. If LDAP stopped working, Blackboard would also stop working, as no one could log in. The second type of service dependencies is that a service requires another service for some features. For instance, Blackboard uses lecture recordings. However, if the lecture recording system breaks, Blackboard will still operate, but will not be able to show lecture recordings. The third type of service dependency is for updates. In this example, if the student system breaks, Blackboard will still work, but new students and courses cannot be added. If every service owner enters service dependency details for their services, we can build up a big picture of how IT services fit together. Using this approach, we can see that Blackboard is dependent on more than the 2 original services, as those services also have dependencies. The final piece of information we want to capture is data center dependencies. The engineer can enter the data centers where the equipment is located and what the failover capabilities are. Calculating the service risk. By processing the data captured for each service, we can calculate the target and actual CIAs. The target confidentiality is determined by looking at the data stored by the service and using the value of the most confidential. Each data type is classified for confidentiality using a central lookup table. By looking at the security measures in place, we can determine how well the data is being protected. Each control in place adds to a score giving an actual confidentiality value. Here we needed a value of 7 and are achieving 9, so we have effective controls to protect the data. We can do the same for integrity. Looking at the answers to the questions, we can determine the integrity requirement as well as the controls in place to protect the integrity of the data. Here we are achieving our integrity target. And again, for availability, we can determine availability targets and the controls in place to achieve those. In this case, we are achieving our targets for availability as well. So in this instance, we can say we are running this service properly. Imagine, however, that instead of running Blackboard on clustered or load-balanced servers in secure data centers, I ran it on my PC, in my office. Then, there aren't enough controls in place and we aren't achieving our targets. ServiceView is able to recommend improvements of how the service could be run better. In this instance, we are not running this service well. Even if we aren't running a service well, it might not matter. Some services are more important to the organization than other services. Services are classified by importance to the business. The most important services are classified as Tier 1, then Tier 2, etc. Blackboard is a Tier 1 service as it is of significant importance to the organization. Any service that Blackboard depends on must also be classified as Tier 1 as well, as an outage in these will result in an outage of Blackboard. By combining how well are we running a service with how important the service is, we can calculate the residual risk. Low, moderate, high, or significant. However, when it comes to data confidentiality, we can't rely on hackers only targeting Tier 1 services. They can equally target any service. So we need to use how well are we running this service with what data does this service use to determine the confidentiality residual risk. There are several ways to extract the information in a meaningful way. Any of the 20,000 items of information collected about each service can be charted graphically. In this example, we are seeing which IT services are using different types of data and the residual risk of each service. ServiceView can also generate a data center dependency and recovery plan. A list of possible disaster scenarios are modelled by the technology. For each disaster scenario, the affected services are listed, and a service restoration plan is automatically compiled using the service and data center dependencies stored in ServiceView. A complete risk report can also be generated. By combining all the services, the service dependencies, the target CIAs, the actual CIAs, the data stored, and the priority of each service, ServiceView can generate a complete risk report. The risk report contains a summary of high-tier services, a one-page report on each service indicating its risk level, a service register documenting each service and its purpose, an information asset register detailing which IT services stored which data types. This is required by law in the Information Privacy Act 2009, and a technology asset register organizing services by their technology. In order to prove this process works correctly, we can make a minor change to one of the services on which Blackboard is dependent. If we swap the VM farm the Kerberos system runs on from a highly available farm to one that is less highly available, and we regenerate the risk report, there are significant changes. Blackboard is now a significant risk. Looking at Blackboard in detail, the report highlights the availability risk and recommends the availability of the VM farm is increased. In conclusion, we have captured a wide range of IT systems which usually go unnoticed in conventional audits. We have a huge database containing service details and owners. We understand how services depend on each other and data centers. We can generate reports periodically as required. With good communications to the right stakeholders, we get enthusiastic buy-ins from service owners. If you think your institute could benefit from a similar IT audit, or for more information, please email me.